Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing, mimicking, waiting to be told or shown what to do. But y'all, it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms not particularly helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
So in today's episode, we are going to have some fun beating around a term that is often used in math classes.
Yeah, so Kim, I just got back from spending time in Utah, which is totally cool because I got to see my kids, yay!
Yeah.
With some wonderful high school teachers. We've actually met a couple of times, and we had some great conversations, a super interesting conversation about some words we use in math teaching that have the potential to be super confusing because, well, for many reasons, but I'm going to suggest today because they're not well defined. Which is interesting for a group of people who are all about definitions and
Right.
that, right? So it reminds me of a story that I heard Dylan Williams say one time, which I think there's no S, right?
Yeah.
Dylan Williams.
No.
Yeah. Sorry about that, Dylan. He's all about assessment. He's a good speaker. I've learned some things from him, and I really appreciated this story. He talked about the word similar in mathematics. So the word similar in English has a very specific mathematical definition. But in everyday usage, we, similar, Kim, you and I are similar in some ways, right? I mean, we live close near each other. We both taught math. How else are we similar? We're both women. We both have kids. I don't know. There's some similarities that we have. We both like chips and salsa. Though you might like it more than me. So we have some there's this word similar in everyday language that means, we're kind of alike. We kind of have some things in common. But in mathematical definition, it's very particular. It has a very particular meaning. And he suggested that, and I don't remember the country he was in, but I'm pretty sure it was an Asian country, that in that particular country, when you get to similarity and you're talking about that shapes can have the same shape but different size, that the angles are congruent on a triangle, therefore the triangles are similar, but they can have a small triangle that's equilateral and a large triangle that's equilateral, but they're similar. That definition of similar is very similar shapes, very specific definition. Right. That in that Asian language, they made up a word. That they don't use a commonly known word to then have a specific different definition. They made up a word. And so when kids in that country learn about similarity, the mathematical definition of similarity, they don't mess it up. That because there's this that's interesting, right?
That is interesting.
There's this very specific word that has a very specific definition, and it's only used in that way. Kids don't mess up similarity in the same way that they do when the language is not well defined. That's what I mean. Like we have this word that can mean so many different things. Oh, but in math, it should be this. But kids have a hard time parsing that out. And I don't know, maybe we as teachers could do a far better job of parsing out what the mathematical meaning of similarity is versus, this sort of commonly used word.
Yeah. That's interesting.
right? It's
So
fascinating.
yeah, it is really cool. So there are these words that we often say that have different meanings. And so today we'd like to focus on one of those words, which is simplify. And we've actually mentioned this before because we did an episode, oh gosh, way back when, I don't even know the number. It's like
We'll
maybe
put it in
even
the
in the
show notes. Yeah.
teens. Yeah.
Hmm.
That we did a this not that episode, and we tackled some of the words in mathematics that people use that make us cringe just a wee bit. And one of the words that we said that we don't say is reduce. And what I said at that time and what you said at the time was, I kind of use the word simplify, but I mentioned it and you were like, okay, but there's got to
Neither
be
of us
something
love
better.
it.
Yeah.
Yeah. Yeah.
So
We
we're going
for
to talk about
sure,
that today.
well, so to be clear, we for sure don't like the word reduce
Reduce.
when we're talking about fractions.
Yeah.
Because if we're messing around with fractions and we use the word reduce to mean create an equivalent fraction where there are no common factors between the numerator and denominator,
Mhm.
the word reduce feels like get smaller. And often the numerator will be a smaller number than the previous numerator, and the denominator will be a smaller number than the previous. I should give an example. We're being really esoteric here. So like if I was talking about 12/15ths,
Mhm.
and a textbook might say reduce that fraction, then you might say, well, okay, like I can see that there's a factor of 3 in each of those. So 12
Mhm.
15 divide out of 3 out of the 12, and that's 4, and I can divide a 3 out of the 15, and that's 5. And so 12/15 is equivalent to 4/5. And you
Right.
might say, well, yeah, like 4 is smaller than 12 and 5 is smaller than 15. But the fraction 4/5 is not smaller than 12/15. So we
Right.
hate the word reduce when we mean find an equivalent fraction
Right.
that maybe you've reduced the number of reduced common factors between the numerator and denominator. That's how some colleagues of mine once said, no, reduce totally makes sense because you're reducing the number of common factors. There's no common factors now between the numerator and denominator. And I'm like, yeah, okay, but it's
But
still
that's not what kids think.
not in any way, right? So you can sort
Yeah.
of explain why we use this horrible
Yeah.
word to
Yeah.
mean what it doesn't really mean. But we don't like it because it sends such a not a message we
Confusing message. Yeah.
confusing message. Yeah, absolutely. And that's specifically when we're talking about fractions.
Right.
So we said, so we can use the word simplify, but like you said, neither of us really love that because simplify, does that really work when what we mean is find an equivalent fraction? Like is 4/5 simpler than 12/15? Uh,
Yeah.
yeah, like you could maybe make an argument that thinking about 4 pieces out of 5 pieces is simpler than thinking about 12 pieces out of 15 pieces. You could try that argument. But
Yeah.
again, we don't really love the word simplify either when it
Mhm.
comes to to simplifying fractions.
And
That's
at the
funny.
time, we just kind of left it. We were like, ugh.
Yeah, yeah.
But now you've had some more opportunities to think about that, right?
I have. And so what's interesting is okay, I gotta tell you, I've been trying to find the this not that episode as we've been talking. And so I'm a little distracted. It might be episodes. No, that's not it. Okay. Oh, maybe I just found it. There it is. It's episode 18. So if you want to go back,
Okay.
and that was a while ago. So episode
Yes.
18, we talked about some this not that things. But like you said, we've gained some clarity, or I hugely this last weekend when I was in Utah and I was talking to some teachers, I gained some clarity about the idea of the word simplify. When I was dealing with these high school teachers in Utah, it occurred to me, partly because they were suggesting it, that we don't just use the word simplify, and I know this, but we don't just use it with fractions. We use it in lots of other places to mean other things. Like the word simplify is super confusing, not just because it doesn't relate well with when we're finding an equivalent fraction, but it has other places where it's not well defined. It can mean other things. So let me give you some examples. Let's stay with fractions for just a second. Notice that I could have that 12/15 being equivalent to that 4/5, but you lose information, or you run the potential of losing information about the context. So for
Mm.
example, let's say if I was talking about making 63 out of 119 free throws, you might be like, okay, well, I kind of have a feel for that. But if I just simplify that so that it's about 2 out of 4, and it's just about 2 out of 4 on that one, then you've lost some information. You don't
Mhm.
know how many total free throws I was shooting. I mean, if I just said to the coach, hey, like 2 out of 4 free throws versus 63 out of 119, I might be like, whoa, that kid shot a lot of free throws that day.
Yeah,
Versus,
yeah.
like you lose, you run the potential of losing information. So that's just one way of thinking about how it's not super with respect to finding equivalent fractions. But also, we might send the impression to students that if they say, back to my 12/15 example, if they say 12/15 and I mark it wrong because they didn't
Mm.
simplify it or they didn't write an equivalent fraction that's in simplest form. See, we don't have really good words for this. They didn't write a fraction where the numerator and denominator are relatively prime. That's kind of a complicated way of saying it. Like, how could we say, write a fraction that's equivalent, rewrite this fraction that's equivalent so there's no common factors in the
Mhm.
numerator and denominator? That's a way
Mhm.
of saying it. Boy, super
Mhm.
complicated. If we mark 12/15 wrong because they didn't write 4/5, I worry that students think, oh, so 12/15 doesn't correctly represent the situation, when in
Right.
reality, it might represent the situation better than four
Right.
fifths.
Right.
So this is kind of a super tricky, like, I understand that teachers often want to have 4/5. They're like, yeah, but like, I want to be able to see, can students find the equivalent 4/5 to 12/15? But I think we might want to be at least clear with students, at least at a minimum. Teachers may invite you, be clear with students. The 12/15 is not incorrect.
Right.
It's equivalent. It's just
Right.
maybe not the answer you're looking for. And can we then maybe agree that it's convention that we're looking for that maybe easier to grade answer? That
Mhm.
that maybe we're actually looking sometimes, and maybe not all the time. Maybe we really do want to know if students can factor out those common factors, divide out those common factors. Maybe we are really we do want to say that, but maybe we ought to say rewrite that fraction and divide out all the common factors from the numerator and denominator. Something like that,
Uh-huh.
but not give the impressions incorrect. But could we at least admit that sometimes we're asking for that simplified version of the fraction because it's easier to grade? And at least
Yes.
admit that to
Yes.
students.
Yes.
Like, it's
Yes.
easier to grade
Yep.
if all we're looking for is that fraction where there are no common factors in the numerator
Yeah.
denominator,
Yep.
because it's easier to grade. So at least admit it. Tell students,
Yep.
hey, it's just easier for me to grade if you'll do that. But they're not wrong. Like, let's
Right.
just say 12/15 is not incorrect. It's just has common factors in the numerator denominator. And I want to know today if you can factor out those common factors.
Yeah.
Divide out, I
Yeah.
should say, divide out those common factors. And so,
Yeah.
let's at least be clear with kids on that. But then in this conversation with those high school teachers, they helped me become a little bit more clear that it's not that's not the only time we use simplify. And I got kind of interested in that. I started thinking about all the times we use simplify, because we do. So then one of the participants in the workshop, super guy, his name is Travis Lemon. Travis and I have actually worked together for several years. He reminded me that we met, golly, my daughter's 22. So you might be like, why are you talking about your daughter, Pam? Because we met when I was doing a workshop in Utah when she was, golly, probably 6 months old.
Oh,
That's how
wow.
I know, because I took her to the workshop with my cousin. I think she was more like 3 months old. It was in Utah, and my husband and I, we took all the kids out and everything. And my husband, during the day, the workshop, he took the kids to the dinosaur museum, and I took Abby to the workshop and did the workshop. And then at break, I would go nurse her because I was breastfeeding her at the time. And my cousin sort of took care of her during the time. And then, like, during the break, I'd be like, I chat with my cousin while I nurse. Now we go back and do the workshop. So I can tell you exactly when we met, because I totally remember that's how old my daughter was. And I met Travis then, and I was doing some work with algebra. And it's so cool to have this long-term relationship with this fantastic teacher. And he said, yeah, we've really been working on that. So we being, Travis is one of the authors on the Open Up Resources curriculum for high school. So it used to be called MVP.
Mhm.
And then they went to Open Up is now publishing them. You can get it for free. I highly recommend it. One of the main creators of MVP, or Open Up Resources High School, is Scott Hendrickson, who was the teacher who hired me for my first teaching job. So I have a long connection with these folks that are writing this curriculum, and I really honor the fact that what they're doing is in their latest version, they're trying to eliminate the verb or the command to simplify.
Hmm.
And as Travis was talking, he said, because there's so many different times we say simplify when we mean different things. And I said,
Yeah.
like, give me some examples. And the more he talked, the more examples I was coming up with. And he actually sent me some screenshots of places where they were replacing simple. Well, I said, it wasn't me actually. Somebody in the workshop said, well, what's a better word? And when I told the Dylan Williams story, I keep giving you an S. Sorry, Dylan. When I told that story, they said, oh, well, then we should make up a word in English like they did to, like for similarity. We should make up a word for simplify. And Travis was like, because we use simplify to mean too many different things. And as they've tried to replace simplify, they've actually replaced it with phrases. So let me give you a couple of examples. So, for example, there was a place where they had problems like 5 times 3x minus 2, 5 times the quantity,
Mm-hmm.
3x minus 2. So you can picture 5 parenthesis, 3x minus 2, and the parenthesis. And in a typical textbook, the instruction might be simplify the following expressions. And you would expect kids to then like, well, here's the instruction that they wrote. So it doesn't in Open Up Resources High School, it doesn't say simplify the following expressions. It says rewrite the following expressions using the distributive property. So then you would expect kids to use the distributive property to say 5 times 3x is 15x, and then distribute that 5 times the negative 2 and minus 10. So they actually, there is no instruction to simplify. It's rewrite the following expressions using the distributive property. I'm not sure I love rewrite the following expressions using the distributive property, but it's what they mean.
Yeah.
So there you go. Here's another example. Let's say that you had, now I'm giving some high school examples. We'll give a couple of younger examples in a minute. Let's say that you had 2x times the quantity 5x plus 3 plus 7 times the quantity 5x plus 3. You could say simplify. And often the instructions in a typical textbook would say simplify when we mean, and here's the instructions that they wrote, rewrite each expression as the product of 2 binomials. Now, I know that sounds like a lot of math speak to you, but you might notice that there was a 5x plus 3 that was common. And so you can sort of factor out that 5x plus 3, and you end up with the multiplication, the product of 2 binomials. And there's sort of, can you undistribute? So can you pull that 2x and that 7 out to get the quantity 2x plus 7 times the quantity 5x plus 3? And I know I'm doing a lot in the air here. You'd almost have to write that down to be able to sort of see what's happening. But it's a way of kind of, typically kids would take the 2x plus 7 times the quantity 5x plus 3, and then you could distribute that. You could think about that as 2x times the quantity 5x plus 3 plus 7 times the quantity 5x plus 3. And so they're in this case, they're kind of undoing that distribution.
Yeah.
But you're being clear about what's happening. So here's another.
You know what I love? Hang on
Yeah,
one
go ahead.
second. You know what I love about that is that the mathematical vocabulary that they're using here, instead of simplify, they're saying expression and product and binomials. Like it gives the kids a window into what is happening, but also using correct mathematical vocabulary that we want them to understand anyway.
Yeah. So you might say, kids can't use that kind of vocabulary. And what we're suggesting is, as you just say simplify, but expect kids to know that they're supposed to do this other thing. Each of these instances that we're using so far, kids are expected to do something completely different. And it's almost like we have this secret club. And if you've done 1 through 29 odd 29 times, you kind of get a feel for when simplify means use the distributive property, and you get a feel for when it means undistribute, and you get a feel for when it means rewrite the fraction so that there are no common factors in the numerator and denominator. You get a feel for what simplify means. But if you don't ever get that feel, we haven't been explicit about what simplify means in these different cases. We're kind of expecting kids to guess what's in our head. We're kind of expecting them to just like know, oh, in this case, this is what it means. Oh, but not in that case. Let's actually be clear. And I think these guys are doing a great job of at least admitting, hey, this is what we mean in this case. We actually mean that. And I think, yes, it might mean that in this case, we actually have to help explain those terms. that these commands are sort of meaning, but that's better than saying, guess what we mean here by simplify.
Yeah.
Yeah, cool. All
Yeah.
right, so let me give you a couple other examples. Here was one where it was x times the quantity x plus 9 plus 2 times the quantity x minus 2. And often we could just say simplify. It might, I've seen places where it would say simplify and collect like terms.
Mm-hmm.
In this case, they said multiply using the distributive property, then add like terms,
Mm-hmm.
giving a clear instruction about what to do. You know, I can
Right.
almost picture some of the colleagues that I've taught with saying, no, we're giving away too much. We're telling the student what to do too much. They should know that. They should be able to look at that and know what to do. I'm going to push back on that. I think it's actually why it's almost like we're saying, if we do that, we'll level the playing field too much. How about if we
Mm-hmm.
level the playing field?
Right.
Like, I don't think it's necessarily a nice thing to make kids have to guess what we mean. Here's another example. Rewrite each of the radical expressions to remove perfect squares from inside the radical. Now, if all those words are like crazy to you, let me give you an example. If I write the square root of 50, so you can picture the square root symbol with the 50 inside. If I write square root of 50 and say simplify, you might look at that and go, looks pretty simple to me. Like, what does the
Yep.
word simple mean? And in fact, I probably could have said that for all of those expressions that I just said above. It's kind of in the eye of the beholder whether
Right.
it's more, one of the versions is more simple than the other. In fact, two of the examples that I gave a minute ago were the exact inverse of each other. So if you say simplify when I mean multiply them out, and I say simplify when I mean factor them back to the other direction, then you've used the same term to mean go one direction and then reverse and go the other
Yes.
direction.
Yep.
So being more clear. So if I have the square root of 50, I might look at that and go, I don't know what you mean. Oh, except it just said, rewrite this radical expression to remove perfect squares from inside the radical. So then I got to think to myself, are there perfect squares in 50? Oh, sure enough. Like I can think about 25 times 2. So now I'm thinking about the square root of 25 times the square root of 2. Square root of 25 is 5. So at the square root of 2, there's no perfect squares inside 2. And so then I can say to myself, the square root of 50 is equivalent to 5 times the square root of 2. I have removed a perfect square from inside the radical.
Yep.
So much more clear. Kids kind of know what to do. One last example that Travis sent me. Thank you, Travis, by the way. Super enjoy working with you. Was rewrite each expression by performing the indicated operation. Each new expression should contain only one square root. And so these were examples where there were lots of square roots happening, and you could combine so that you only have one square root. So it's almost like you're kind of going the other direction. You're taking now a bunch of square roots and you're sort of squishing them all under the radical, instead of like that square root of 50 where you're taking one square root and you're kind of like, or at least one number under square root. And now you end up with 5 times the square root of 2. Now you have like multiple things happening. So it's kind of, again, that sort of different direction. That's kind of important. Like we can actually help students understand what we mean, what their task is, by replacing the word simplify with what we actually want them to do. Okay, so let me think of a younger example. I think the best example I could think of with younger students that are dealing with younger students would be simplifying fractions. I'm not sure I can think of, Kim, can you think of an example where would you simplify a division expression or simplify?
Not off the top of my head.
Yeah, really, I can think of simplifying fractions. And then it's kind of comes in more when we have variables. So I could picture something like 2x plus 3x minus 5y plus y. And I could picture a textbook that says simplify, when in reality, what they mean is collect like terms or
Right. Right.
rewrite the expression so that, how did they say that? Rewrite the expression so
By
I'm trying to
performing the
find.
indicated operation.
Yeah, or add like terms.
Yeah.
Combine like terms, add like terms. Either way, yeah. So I think we can use phrases to say what we actually mean. You might have a textbook that is replete like everywhere that just says simplify all over the place. May I encourage you to at least begin you thinking about what it actually wants kids to do in that
Yeah.
case.
Yeah.
Like,
Yeah,
are you
absolutely.
clear? Yeah. Could
Mhm.
you replace simplify with what you're actually expecting kids to do in that case? Y'all listeners, I'd love to hear some examples that you find as you're teaching. Where do you see the word simplify asking students to do something? And then either send us what phrase could you replace that with,
Yep.
or ask, like, let's ask the world, how could we all come up with better ways to ask students what we actually mean for them to do when they see that word simplify?
Right, right. Because if our gig is to make math more and more figure outable, we can't leave them guessing what's in our head
Exactly.
or what's in a
Yeah.
textbook's head, right? So let's cancel the word simplify and say what we actually mean.
Nice, nice. All right, y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figureoutable movement, visit mathisfigureoutable.com. Let's keep spreading the word that math is figureoutable. Thank you for listening and making math more figureoutable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figureoutable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.